Let's look at another maximization problem. A rain gutter is made from sheets of aluminum that are 20 inches wide by turning up the edges to form right angles. Okay, so let's take my horrible drawing skills and put them to the test here. So here's a sheet of aluminum, and this sheet of aluminum is 20 inches wide. Okay, now what they do to create a gutter is they come in off the edge and they fold this aluminum. And what they end up with is, let's see if I can actually, let's try it like this. Hold on, guys, bear with me. I'm going to draw this. Okay. What they end up with is this gutter. Let's see. Yeah, that'll work. Okay. So if you would think of this as sort of like this alleyway, okay, where the water rushes through here, right? And then the water is carried, right? Is carried through the gutter, right? So we're taking these sides and we're folding them up and we're creating this alleyway for the gutters to go through. So cross sectionally, if you would, right, where we're viewing down, this is what we're creating. And if you take the distance from here to here to here to here, that's our 20 inches. That's this distance right here. So hopefully my drawing is making sense. And again, we're trying to maximize this cross-sectional area. So a cross-section is where you cut something and you look at it from the side. So we're maximizing this area. And we realize that it's not a closed shape, but it's really a rectangle, right? And so again, when they say determine the depth of the gutter, the depth of the gutter would be this distance, right? And that is this fold that we're folding up. So this distance, this is the depth, which is the same as this mark right here, okay? Now we're turning up the edges to form a rectangle. So this distance is the same on this side as it is on this side so that the depth is uniform in this direction and here as well, okay? And we'll call that X because we don't know, all right? We don't know what that is, but we're gonna form this rectangle to maximize that. And we want to maximize, what are we maximizing? The cross-sectional area. So again, we're maximizing the area. So when we're maximizing a function, we need to write something in terms of x. Okay, so we need an area formula for this gutter, for this cross-section in terms of x. Okay, now we know what area is. Area is, it's length times width. If you want to write it out, go ahead, right? It's length times width, right? But those are two unknowns here, right? And if we're going to graph this, we're only going to be able to graph it in one variable, right? So the x, everything has to be defined in terms of x here, because that's what we're going to plug into our graphing utility. Now, I don't know what the length is, but we can call the width or the depth here. That can be our x term, okay? So what's the length? How do I express this distance? All right, and again, that distance is this distance, which is this distance right here. Okay, not the full 20, but the distance from here to there. Okay, and what is that distance? Well, if the whole sheet is 20 inches and we have to fold up x on either side, then this distance is the 20 inches of that sheet minus the two x's that we have to fold it up, like we said. So from here to here to here to here, that's the 20-inch sheet. We're folding up x on each side, so what's left is 20 minus 2x. So our equation looks like this, right? And again, when we go to graph this, don't plug this into your graphing utility, distribute the x. So we're looking at a function that looks like this now instead, okay? And what will this be? Just by looking at this function, we realize it's quadratic, and the leading coefficient for x squared is negative. So we know that it's going to open down, and it is going to have a maximum value. Okay, so we go to our graphing utility and we type that in, 20x minus 2x squared. And we've got to mess with our window. We zoom all the way out and we find our maximum value is 50 when x is 5. Okay, so we know that our max, get my pen back here for a second. We know that our max is y equals 50 at x equals 5. So when they say what is the maximum cross-sectional area, the area is the y value here, right? So it's 50 square inches is our max area. And what is the depth? The depth occurs when we make that 5 inches. So depth is 5 inches. Okay, so again, when it comes to maximizing, we need to have a function based solely on x. We can't say x and y. We can't say L and W. We have to have both of these measurements in terms of x. Then we graph and we find that top of the valley there. Okay, top of the hill, not the valley.